In this video, we're going to continue working through some practice problems that involve simplifying trigonometry expressions. So these are all the problems that we're going to run through. If you want to give them a try yourself, you can pause the video and do that. Otherwise, we're going to jump into question 13. Starting with question 13, we have cosine squared t minus 1 over sine squared t minus 1. So in order to figure out what both of these actually represent, we're going to use our trig identity, cosine squared t plus sine squared t equals 1. And what we're going to do is we're going to subtract this 1 across. So this becomes cosine squared t plus sine squared t minus 1 equals 0. Now what we can do is we can subtract one of the trig functions across, and what we're left with is something that shows up in our problem. So cosine squared t minus 1 is equal to negative sine. So we'll write this out here. Then you can imagine that if we do the same thing, but subtracting cosine squared t on both sides, we're going to get sine squared t minus 1 equals negative cosine squared t. So basically just repeating the process, but subtracting cosine squared this time. So our expression now becomes negative sine squared t over negative cosine squared t. Negative over negative is a positive, and sine squared over cosine squared is tangent squared. For question 14, we have cosine t times cosecant t times the quantity secant squared t minus 1. This one's an interesting one. It takes a couple steps, but what we're going to do first is rewrite the first two in terms of cosine and sine. So cosecant is 1 over sine t. Then we will recognize that this component is equal to tan squared. So our original trig function is 1 plus tan squared t equals secant squared t. So subtracting the 1 across gives us that tangent. Now what we can do is write our new function in terms of cosine and sine. So bring it down to a new line here. And then this is going to be sine squared t over cosine squared t. So that's what this becomes. Now we can do a bunch of canceling. This and this little exponent, and then sine and one of these exponents. And what we're left with is sine over cosine, which is tangent t. For question 15, we have secant t times tangent t over tan squared t plus 1. So first step here is going to be to rewrite the top as in terms of cosine and sine. So secant is 1 over cosine t, and tangent is sine t over cosine t. On the bottom, we recognize that this is the trig identity for secant squared, so we can rewrite that, secant squared t. Now what we're going to do is rewrite this as 1 over cosine squared t, since secant is the reciprocal of cosine. So on top, we're going to have 1 over cosine t, sine t over cosine t. At the bottom, we have 1 over cosine squared t. Now we can flip this around so it becomes cosine squared t over 1. Actually, let me just get rid of this. 1. And we can do a bunch of canceling. So cosine cancels with cosine squared, and we are left with just sine of t. Beautiful. For question 16, we have sine squared t times cotangent squared t over 1 minus sine squared t. So first thing we recognize is that this is one of the trig identities for cosine squared t. So we can rewrite this. Sine squared t, cotan squared t cosine squared t. Then we see that we have a sine squared over a cosine squared. So this can be rewritten as tangent squared t times cotangent squared t. And because these two are reciprocals, we are left with just one. For question 17, we have cosine squared t minus 1 over cosine squared t times tangent squared t. So we actually figured what this was in a previous problem, and this is negative sine squared t, which comes from one of our trig identities. On the bottom here, we can rewrite tangent as sine squared t over cosine squared t, and then our cosines are going to cancel out. It's going to leave us with a negative sine squared t over sine squared t, and those cancel as well. So we have a negative 1 left over. For question 18, we have cosine t times secant t minus cosine t. So this one's not actually too bad. What we're going to do is simply rewrite secant t as 1 over cosine t minus cosine t, and then we're going to distribute this cosine t. So we're going to have cosine t over cosine t minus cosine squared t, which gives us 1 minus cosine squared t, and from our trig identities, this is sine squared t. For question 19, we have cotangent t times tangent t plus cotangent t. This one's, again, not too difficult. We know that cotangent and tangent are reciprocals, so we're going to distribute this cotangent, and we're going to get 1 plus cotan squared t. Then we recognize this as a trig identity, and this is cosecant squared t. For question 20, we have tangent t plus cotangent t over cotangent t. So what I'm going to do first is break this up into two separate expressions, tangent t over cotangent t plus cotangent t over cotangent t. Then we're going to rewrite this first part in terms of sine and cosine. Sine of t over cosine t, which is tangent. Cotangent is the opposite, cosine t over sine of t. And then when we divide by a fraction, we flip it. So we're going to have sine of t over cosine t times the sine of t over cosine t. And this first part becomes sine squared t over cosine squared t. And then we got to bring down our other piece of this expression, which is going to be just 1. Then we can put this back into tangent form. So sine squared over cosine squared is tangent squared t plus 1. And this is a trig identity, which is secant squared t. For question 21, we have tangent t over tangent t plus cotangent t. So first step, we're going to rewrite the bottom as tangent t plus 1 over tangent t, since cotangent is the reciprocal of tangent. Then we want to get a common denominator for this bottom left term, so we're going to multiply it by tangent t over tangent t. This lets us rewrite the entire expression as tangent t over tan squared t plus 1 over tangent t. Now, dividing by this fraction, this becomes tan squared t over tan squared t plus 1. On the bottom, this is a trig function for secant squared t. So this becomes tangent squared t over secant squared t. Now, we rewrite this using sine and cosine. So we're going to have sine squared over cosine squared t all over 1 over cosine squared t. And again, dividing by this fraction lets us cancel out these cosines, and we are left with sine squared t. For question 22, we have secant t plus cotangent t minus cotangent t times cosine t. The key to this problem is to rewrite everything in terms of sine and cosine. So we're going to start off by doing that. Now we can cancel out these cosines, and we have the same denominator on each term, so we can write the top as a single expression, cosine squared t over sine t. 1 minus cosine squared t is equal to sine squared t from our trig identities. Put this over sine t, and then we can cancel this and this, and we are left with sine of t. For question 23, we have sine t times tangent t minus cosecant t times tangent t. This problem is similar to the previous one, where all we really need to do is rewrite everything in terms of sine and cosine. So let's do that here. When we do this, we see that these signs will cancel, and then we can rewrite everything as a single expression. On top, we have a trig identity for cosine squared t over cosine t. This cancels, and we are left with cosine t. For the last problem of this video, we have cotangent squared t times cosine squared t over cotangent squared t minus cosine squared t. So it's a little tricky, but we're going to use one of our trig identities, and we're going to solve for cotangent squared t. So we're going to subtract a 1 from both sides. Then we're going to replace this portion of the expression. Cosine or cosecant squared t is actually equal to 1 over sine squared t. So we're going to rewrite it like this. And then we're going to multiply that cosine squared t across. So we're going to have cosine squared t over sine squared t minus cosine squared t. Then we're going to bring back our denominator. This part here, cosine squared over sine squared, is equal to cotangent squared. So probably see where we're going with this. But in the end, we have cotangent squared t minus cosine squared t over the same thing, and we are left with 1.